Hi guys, today we're at 27 Feb and we've got two exciting news. The first one is OpenAI finally released GPT 4.5, and 2 days ago Sonnet released 3.7 model and also 3.7 Sonnet thinking. And today we're gonna make them punch each other through three things. The first one is through chess, which actually Levi Rosman, shout out to him, has been trying, but in a very ugly way. Sorry, Levi. We're gonna do it in more professional way, more engineering technical way, by doing some prompt engineering to really take the most and especially the thinking part of the model to really judge the new thinking ability that got added and reinforcement learning part to these models, but also will make them fight through math and through logic. And why I do that, it's not only for fighting, but it's for two other reasons. It's to rank them, find which one is the best, but also to really figure out how the thinking and reinforcement learning works. Because this is the big addition of 2025, is this magic of reinforcement learning and thinking ability that got added to DeepSeek R1 and O3 Mini High and now Sonnet and also GPT 4.5. So I think this platform that I created and this way to make the models fight each other will really show us many interesting things, but also will help you as an AI user or as an AI somebody who's using it or like it to really judge what is the best model to use for what kind of task. So if you stick with me to the end of the video, you'll see a lot of fun, but also a lot of technical interesting details. Directly begin the fun. So here, what you see, I'll be playing 4.5, which is the exciting one that just came today, and 3.7. You can see here that I have the full chest position, but to make my cat is screaming there. But I'll be simplifying the position, so we'll be quick to see. So I built this simple position where white has a plus, and we'll see if GPT 4.5 can quickly checkmate black. So I'll go back to my code, and you can see here I have this initial position here. Yes, so you can see the notation of the simple position, and I'll start my backend code. Okay, now we are ready. And let's begin some fun here. So if I refresh, we should see the new position. I'll put the two models. Okay, now let's start. So you will see as soon as I start, you can see now the game started here. Oh, I've got some check from GPT 4.5. Another check by the queen. Oh, it's gonna pick up. Oh, what a check! Oh, what a checkmate! That's a beautiful checkmate. How amazing is that? Like, this is the first time I've been trying this for a very long time. This is the first time I start seeing this fancy calculation done by those models. And now let's talk a bit why this is happening, why this is interesting. Because you might be wondering what is different with that. Like, they are just models. They're trained for chess. They are not. That's the thing about this. So the large language models are trained to generate language. So all of the tests that you see, even if you do tests yourself, there is a secret, something I didn't show to you here. They are very bad at playing chess. Why? Because to play chess, there are specific ways to train models. And the model that knows to play chess, they are not GPT, they are not Claude, there are other models like AlphaZero, like Lila Zero. They do use neural networks and the same kind of learning, but it's very different way and very different way. They don't use transformers. They use more different way of tokenization, a different way of architecture to build the models. So the point is, before this 2 months, before those models they get added the ability of thinking, they were very bad at playing chess. You can try them, and we can also try them this platform. But now the fascinating thing is they only start playing well, even this GPT 4.5 and Claude, when I prompt them, like I tell them some principles of chess. And that's the part I didn't show you. So if you see my code, I added my code so we'll be playing the moves between them, but every time he will tell them to follow these simple chess principles. And that's what's fascinating. The thinking models, particularly the GPT 4.5, to be honest, and O3 Mini High, do really suddenly start playing well, which really tells you that the thinking model, the thinking parts, or the reinforcement learning is really acting, is really giving a big plus, which is kind of like exciting but also scary. Because if I remove this prompt here, you will see that they start playing really bad moves. But also you can see how powerful GPT 4.5 is. I will do the same with math and logic, but let's first try something else. I'm wondering if I play the same position between them, but now I'll make Claude white and compare it to GPT 4.5. So let's see who is better. Now let's see what Claude will be doing. Okay, starting with the check. I don't think it's very useful unless he pin it. Oh, you see, he messed up. He messed up. Oh, so he messed up, but also GPT 4.5 messed up the defense. But you can see it's already not going well. Like Claude is doing a lot of random stuff. You remember GPT 4.5 quickly checkmated him. And suddenly he doesn't even know how to checkmate the king. That's funny. By the way, if I show you here, you can follow the APIs going. Like each move, it asks one side and the other side replies, and it's taking forever. Okay, let's see. Maybe now he found a way to checkmate him. I think he will be coming if he comes back with the rook to f3. Oh, he's doing it now. The queen to e2. Oh no, it's not good. Let's try again. I'll give him a last chance. Oh, that's terrible. Okay, they will say forever. Okay. Okay, good. So the point of this short video is really to tell you that when these large language models, the ones that got added to the thinking part, especially this 4.5, which is amazing that came today, honestly, because I was doing a lot of tests like this, and O3 was good when I give him those principles, but not as good as this GPT 4.5. And that's the scary part, that this thinking stuff is really working. And also I noticed something very weird about some of the other thinking models, like DeepSeek R1, Sony 3.7, and which other thinking model, even the non-thinking one. I was giving them some position and they always play the same wrong move, which was very weird for me. Like, are they just remembering that position? Are they using the same data set? Like, it's a bad move, but they all play the same bad move. So it's really interesting. Now, if you want to see some example of those games, you can find them in this platform I created to render it. Now, before we finish the video, I will show something else. I have also math battles, like fights, and also logic fights. So let's do the math one. It's pretty interesting, and I'll tell you how we'll do it. And I will be giving some very exciting ideas at the end of this. So let's go back. Oh, I forgot. I lost my. Where is my shells? Yeah, here is my shell. Now I start the math one. Oh, the math one is running, but I'll run it again just in case. And now in my little application, let's make them play some math. So again, let's try GPT 4.5 against Sonnet 3.7. So what will happen now is, unlike HuggingFaces or other leaderboards or arenas that ranks the model based on static benchmark or test, which from one point of view, it's very messy and it's very static. But also there is a big risk that because those are mostly static questions, that the models themselves, the companies, might have that intentionally or maybe not explicitly. They just, when they collect all this data to make the training and push it to the transformers, maybe this test themselves, they are there. So, which means all these benchmarks or these rankings might be misleading about the capacity or the intelligence of models. So that's why I believe the way I'm doing, beside chess or for math, for example, what I'm doing here is I'm asking the model himself to generate a very difficult, like PhD level math problem that he knows 100% the answer. Let me show you that. So I go to my math model and I will show you the prompt here. Yeah. So I hope you can see. Increase a little bit. So you are a math expert, create a very challenging math problem that you are 100% sure about the answer. And then I will pass this problem to the other model to solve. And then I will get that solution, give it to the initial model, GPT-4.5, and ask him if it's correct or not. If he says it's not, if he says it's correct, we'll then just start another round. If he says it's false, then what I'll be doing, ask him why it's false, why it's wrong, and I get his like mathematical proof why it's wrong, and I'll pass it back to Claude, and I challenge him, your answer is apparently wrong, and here is why. What do you think? If he also agrees that it's wrong, then I count it like 1-0, and then the battle finish, like all the battle finish. If he say no, it's right, then I consider it just like a corner scenario and I don't count it and we start another battle. So that's how the benefit of that is it's not a static set of questions. It generates it dynamically. It challenges the creativity of the models and also on use cases that probably they never seen it because they are not the same models. And the generation itself, it has some kind of like random parts of it, like stochasticity on it. So let's play a game. Enough talking. Let's play a game. Okay, so let's try. Let's start. Now, GPT-4.5 is thinking. Now this is the math CLI. If I go to the, yeah, you can see the math. You can see the math is going on. He already found the question. Yeah, so he sent some. If somebody is expert about math, can explain to me. I used to be good at math, but this is too difficult for me. And now we are waiting for Claude's answer. Oh yeah, so Claude is already answering. Oh, and you see, like GPT-4.5 considered his proof as correct. So the round will carry on. Now it's Claude's turn to create a very difficult problem. Let's see. Hamiltonian vectors. And GPT also agree about it's correct. It's funny, like just one round before I started the video, I did a couple of rounds and it was quickly finished. One of them was considering the other side is being wrong, but this is actually more exciting. So let's see. Now this is another round. And here is the answer by Claude, I guess. Oh, here we go. So GPT-4, again, every single time I played this so far, GPT-4.5 is the one that wins, which means he found it wrong. And Claude 3.7, he agrees at the end that it's wrong. Isn't that beautiful? Yeah. So I would say as of today, this GPT-4.5 is quite scary because both in chess and math, dynamically new creative challenges he faces, he was extremely good. If you want to see more stuff like that, you can see AI Battle. That's my own platform where I put all these challenges. You can review them. If you want me to try some other way to challenge the models, let me know. And you can follow more about me in update.ai. Thank you, guys.